about 500 meters beneath the surface of Antarctica, in a place where sunlight has never reached, something is alive. Amphipods drifting in complete darkness and isolation for thousands of years. The ice here can be nearly 5 kilometers thick. From above it looks empty, but it is not. Beneath the surface there are vertically flowing rivers, lakes larger than cities, and volcanoes that have been active for millions of years. All of this is concentrated in the largest freshwater reserve on Earth. Now the world's most powerful nations are competing to control it. China is building new stations that will operate year-round. Russia is conducting seismic research in disputed areas. Antarctica is protected by an international treaty that bans mining and territorial claims. This protection may be reconsidered in 2048. And then presence becomes a force that must be reckoned with. So what lies beneath the ice that makes all of this effort worthwhile? What are they really looking for? This is new nature. We spent weeks gathering the latest research from glaciologists, geophysicists, and ice scientists. Antarctica is far more interesting and valuable than it appears from above. To see what countries are truly competing for, we have to go beneath the ice. But first, let's look at the bigger picture. Antarctica is the 5th largest continent on Earth, larger than the United States and Mexico combined. It holds 70% of the planet's fresh water and is covered by an ice sheet thick enough to bury the Alps. It is the coldest, driest, and windiest place on Earth. Temperatures can drop to minus 90 degrees Celsius. Winds can exceed 200 miles per hour. In winter, some parts of the continent do not see the sun for months. Yet life exists here, on the surface, in the ocean, and deep beneath the ice. Let's explore deeper. Antarctica is a library, an ice library. Snow falls in Antarctica and compresses every year. Each layer represents a year, like the rings of a tree. As snow compresses, air becomes trapped between the grains. Tiny atmospheric bubbles become sealed in time. These are ice cores. Scientists study the history of ice in long cylindrical samples. Inside them are tiny bubbles of ancient air. The deeper the sample goes, the further back in time it reaches. This is one of the oldest unbroken ice cores ever found. It was drilled nearly 3 kilometers deep and contains air from about 1.2 million years ago. If it melts, that record will be lost forever. It shows what Earth's atmosphere was like long before modern humans existed. The ice preserves carbon dioxide levels, methane, volcanic ash, and temperature signals. It is a complete atmospheric archive. It records a time when the Sahara was green and mammoths roamed the Earth, when carbon dioxide levels were half of what they are today. The ice does not forget, but this is only the upper layer. Before we go deeper, let's see what happens when snow reaches the surface. Much of Antarctica is covered in bright, reflective snow. But in some places, powerful winds sweep the snow away and reveal something unexpected: fields of blue ice. This ice begins as normal snow, compressed until air bubbles are pushed out. Without fresh snow on top, light penetrates deeper into the ice and absorbs red and yellow wavelengths, leaving a glowing blue color. In some areas, blue ice reveals ice that is hundreds of thousands of years old. In other places, the opposite happens. Snow accumulates year after year, compressing and burying everything beneath it. Then there is Mount Erebus, an active volcano in the far south. Hot volcanic gases escape from vents along its slopes. Where those gases meet the ice, they create warm caves. Inside these caves, scientists have found mosses, algae, and DNA sequences never seen before. Life finds a way even in the most unexpected places. But the strangest thing near the surface is not life. In 1979, Air New Zealand Flight 901 crashed into Mount Erebus, killing 257 people. The terrain was unstable. The ice was constantly shifting. Full recovery was never possible. Snow and ice quickly buried most of the wreckage. Parts of the aircraft, and possibly human remains, are believed to still lie beneath the ice. The cold preserves the past and freezes it in time. As we go deeper, you begin to realize Antarctica is not just ice and snow. It also hides heat, history, and things we were never meant to find. At around 300 meters deep, Antarctica stops behaving the way people expect. Most people imagine Antarctica as one giant block of ice. In reality, two very different things are happening. In West Antarctica, the ice is thinning rapidly. Glaciers are accelerating toward the ocean. Ice shelves are breaking apart. Some of the fastest ice loss on Earth is happening here. But East Antarctica tells a different story. It is colder and thicker. In some regions, snowfall has actually increased the ice mass, at least for now. Satellite measurements show that despite gains in the east, Antarctica as a whole has been losing ice for decades. But the continent is not responding as a single system. That is the paradox. And that is why this layer matters. If we do not understand what is happening in this compressed transition zone inside the ice, we cannot understand what will happen next. So we go deeper. Now you are more than a kilometer below the surface. The pressure here is immense. Water moves between the ice and the rock below. Beneath Antarctica, thousands of rivers and lakes form a closed drainage system. Some subglacial lakes hold volumes of water comparable to major U.S. reservoirs. When they drain, it happens quickly. In some cases, billions of liters of water are released within just a few days. That water can travel hundreds of kilometers across the continent. As it redistributes, the ice above responds. The surface can rise and fall by several meters as pressure changes beneath it. We have barely touched this hidden world. If you added together every place humans have physically reached beneath the ice, it would cover an area about the size of a basketball court. So instead of digging, we fly. Helicopters fly low over the ice carrying massive electromagnetic sensors. These systems reveal what is frozen, what is liquid, and what is moving beneath the ice and rock. Occasionally, this hidden system reaches the surface. A deep red stain flows from Taylor Glacier, spreading across the ice like an open wound. Scientists call it blood falls. When explorers first saw it in 1911, they could not explain it. Algae was suspected, but algae require sunlight, and this water comes from deep beneath the ice. Look closely and the water is actually clear. It is ancient salty brine, more than twice as salty as ocean water, which allows it to remain liquid even at -5 degrees Celsius. It has been trapped beneath the ice for millions of years. Dissolved iron reacts with oxygen when it reaches the surface, turning the ice red. Blood Falls reveals what the hidden rivers beneath Antarctica carry: iron, organic carbon, and nutrients. When this nutrient-rich water reaches the ocean, it fuels phytoplankton, which feed krill, which in turn support larger animals. Everything is connected. The system begins beneath the ice and ends with the largest animals in the ocean. Blue whales are the largest animals that have ever lived on Earth. In the 20th century, humans nearly wiped them out. Between 1904 and 1967, more than 360,000 whales were killed in Antarctic waters. Blue whale populations dropped by 97%. They are beginning to recover, but the problem remains. We still do not fully understand them, where they breed, how they migrate, and what conditions they need to survive in a rapidly changing ocean. Studying animals this large in such remote places requires enormous resources. That is why I joined Planet Wild, a community that funds a specific conservation mission every month. Think of it as crowdfunding for nature. What I like about it is that it is not abstract. You do not just hear about problems, you see the work being done. Every mission is documented and published on YouTube within a few weeks. One mission I supported focused on blue whale research, funding drone-based monitoring so scientists could study whales without disturbing them. The data was made publicly available. Antarctica's ecosystem can only be protected if we understand it well enough. If you want to support this work, you can join Planet Wild. As a thank you, the first 100 people who sign up will have their first month covered. Antarctica's ice feeds the ocean. The ocean feeds the whales. Now let's return beneath the ice. At 3.5 kilometers deep, the pressure is crushing. The darkness is absolute. Beneath the ice lies one of the largest lakes on Earth, Lake Vostok. It is 240 kilometers long and 50 kilometers wide, sealed beneath the ice for millions of years. It has never seen sunlight. It has been isolated from Earth's atmosphere longer than humans have existed. It could contain microbial life unlike anything we have studied before. And Lake Vostok is not unique. Antarctica contains around 700 subglacial lakes. Scientists have already discovered signs of life in some of them. Microbes in Lake Whillans survive by extracting chemical energy from rock. In Lake Mercer, scientists found microbial signatures preserved in sediments. Remember the amphipods from the beginning? They were found beneath an ice stream hundreds of kilometers from sunlight, swimming in total darkness. This makes Antarctica one of the closest natural analogs to icy worlds like Europa and Enceladus. If life can exist under kilometers of ice here, it expands the range of conditions where life might exist elsewhere in the solar system. Antarctica is not hiding aliens, but it shows us what alien life might look like. And the deeper you go, the warmer it gets. Beneath West Antarctica, dozens of volcanoes lie hidden under kilometers of ice. Some are active. The immense weight of the ice suppresses explosive eruptions. Instead, heat builds below, melting ice from underneath and forming chambers of water and steam. Scientists have found volcanic ash layers inside ice cores. Seismic data suggests some of these volcanoes may still be active today. But the volcanoes are only part of the story. Beneath the ice lies the bedrock continent itself, a rugged landscape of buried mountains, ancient valleys, and deep canyons preserved for tens of millions of years. And that is what nations are positioning themselves to control. Because beneath the ice may lie vast resources: coal, oil, metals, and rare elements, potentially worth trillions. For now, the Antarctic Treaty, 1959, protects the continent, banning military activity, mining, and territorial claims. But in 2048, those protections can be reviewed. And the race has already begun. Antarctica is not empty. It is a complex system connecting rock, ice, water, and life. Systems like this take millions of years to form and far less time to disrupt.